bisect each other and the distance between axes of both the prism is 5 mm. So how to draw this problem? So that we draw over here like this. It should be drawn like this. It is shown here. First we draw a square as shown over here. Draw a square like this, and here it is given that the all faces makes equal angle with horizontal plane and vertical plane, means both the axes. Hence we have to draw this square in such a way that these sides make an angle of 45 degree with xy line. So this angle would be 45 degree and this all sides makes equal angle. After drawing this square, insert the dimension, it's a square of 50 mm. Then draw its front view. So for that, from these end points, say 1, 2, 3 and 4, draw vertical lines, and this vertical line will cut xy line somewhere here and prepare this rectangle, this black colored rectangle, and this edge would be visible if you look from this direction. If you look from this direction, this edge would be visible. Hence this line is to be drawn full line. After drawing this front view, let me draw its side view of this black colored prism. So for that we have to draw a line at an angle of 45 degree over here. From here draw projection lines from all ends, from 1, 2, 3 and 4, and from here it will cut at this line at some these points. From those points draw vertical lines like this, and this vertical line and horizontal line from this end we can prepare its side view. So after preparing this side view, draw its axis over here like this. This is the axis of this solid. Here the distance between axis of both the prism is given, that is 5 mm. So here from this axis at a distance of 5 mm on either side, draw another axis like this. This axis is to be drawn. Here I have taken right side, so here draw an axis, and then taking this as an axis, draw another square of 30 mm dimension, side length, such that all sides make equal angle with HP and VP. So it should be drawn like this. In this case, all sides 1, 2, 3 and 4 makes an angle of 45 degree with horizontal plane. So after drawing this square, let me draw its side view and top view. So for that, from say this is point number 1, from 1 draw horizontal line like this, from 2, 3 and 4. So here one rectangle would be there. That rectangle shows the front view of this prism. Then to draw top view of this prism, let me draw vertical lines from each points, from 1, 2, 3 and 4, that will cut this 45 degree line at these points, say 1, 2, 3 and 4, and from those points draw horizontal lines like this, and here this red color prism we can draw its top view here, this rectangle. Now how to find out the points of intersection? To find out the points of intersection, we should start from side view. In side view, let me pick up this point. This point is, say it is point number A, it is on 1, 4 side. So pick up this point, it is on 1, 4. So from here draw a horizontal line like this and vertical line like this. It will cut like this. It will cut over here. This is a black colored square over here. So from this black colored square draw vertical line. So it will cut over here. Vertical line from this and horizontal line from A, both will intersect at this point. Name that point as A dash. Similarly, for point B, from point B take projection line like this, then horizontal line, vertical line from point B, projection in its top view like this, and wherever it cuts this black colored square prism over here, draw vertical line from there. So here point B dash would be there, and A and B is on this side. So if you look from this direction like this, if you look from here, these edges would not be visible and these edges would be visible. Hence the point A and point B would not be visible. Hence they should be joined with a dotted line. Now to find out Rest other points, let me pick up this point number 1. To draw the position of point number 1 in front view and top view, what should we do? So for that, from point number 1, draw horizontal line like this, which shows the projection of point number 1. Now from point 1, draw vertical line, here horizontal line, and that will cut this black colored square over here. This is point number P1 over here. So from this P1, draw vertical line. So here point number P1 dash is there. Similarly point P2, here point number 2 is there. Horizontal line from point 2, vertical line from point 2, here 2, and it cuts P2 over here. So this is point P2. From P2, draw vertical line that will cut horizontal line from point 2 at point P2 dash. So this is point number P2 dash. Similarly, to find out position of point number 3, from 3, draw horizontal line like this, vertical line from point 3, it will cut the square over here. This is point number P3. From that point, draw vertical line. So this is point number P3 dash. Now join P1 dash, P2 dash and P3 dash with a straight line. It's fully visible because it's towards us. If we are looking from this direction, it would be visible. Rest all points, P1 dash to A dash to P4 dash, P4 dash to B dash and B dash to P3 dash, that would not be visible. Similarly, point number P4 dash we can find out from here. From 4, draw vertical line. From here, it will cut the square prism over here. From that, draw vertical line over here. So this is point number P4 dash. Now we have identified all these points. Similar exercise should be done to identify the points on this side also, means drawing vertical lines from all these points. 1, and here instead of taking this point, extend that line over here. It will cut the square over here. Here 2 points are there. 1 point is here, another point is here. Similarly, in case of 4, 1 point is here, another point is here. So from this point, draw vertical line. Here also P2 is here, some point is here. From here also draw vertical line. So same exercise whichever we have conducted over here to be done on this side, and this could be drawn. Now think about this edge 1. Here the penetrating prism is inside this vertical prism. So this portion will not be visible from P1 dash to this point. Hence, they should be joined with the dotted line. Similarly, this bottom portion will also not be visible. So join with the dotted line. And this edge from here to here, it would be fully visible. From here to here, fully visible. And this internal portion will not be visible. So join with the dotted line. So this is a front view of given case. This is left hand side view of given case. Now we think about top view. In a top view, these edges 1, 2, 3, these edges are inside the square prism. Hence, these edges would not be visible. So from point number 4, draw a line like this. So from this point to this point, dotted lines should be there. From this point to this point, dotted lines should be there. And from this point to this point, dotted lines should be there, which shows the hidden edges of the horizontal square prism. So this is the solution of given problem. Here you need to insert the major dimensions, that is square 50 mm, angle 45 degree, 5 mm, that is offset distance, and square of 30 mm. In this problem, length and height of solids are not given to us, so we can assume any height and any length, but it is a general practice to use the symmetrical heights. Means if height is 80, this distance would be 40, this distance would be 40. If length is 80, from here to here 40, from here to here 40 mm distance is to be maintained. So this is the problem of the solution, this question. Now second problem of cylinder is asked. A cylinder diameter 40 mm, height 80 mm. Second problem, the data is given like this. A cylinder is given, diameter of the cylinder is given, data is given in the screen. A cylinder diameter 40 mm, height 80 mm, is resting on HP on its circular base. Here cylinder is given, diameter and height are given to us. It is resting on HP on its circular base. The cylinder is penetrated by another cylinder of diameter 30 mm and length 80 mm. So here the problem is similar to the previous one. The difference is here cylinder is given instead of prism. It is penetrated by another cylinder of diameter 30 mm and length 80 mm. Axis of both the cylinders bisects each other at a right angle. Draw curves of intersection of both the solids. So for this problem, first we draw a cylinder of given dimension, that is 40 mm, as shown over here. The solution would appear like this. So first of all, draw front view, top view and side view of the given cylinder. Diameter 40 mm is given. So first draw a cylinder or circle of diameter 40 mm as shown over here. Then from this draw its center line and draw its vertical lines from here end points, and draw front view, which is a rectangle in case of this cylinder. So this is its front view, and by the method of taking projections we draw its side view like this. So this is the side view of given cylinder, and here it is given that this vertical cylinder is penetrated by a horizontal cylinder of dimensions 30 mm diameter and length 80 mm. So for that, let me draw its side view. In side view, the penetrating cylinder will appear as a circle. So here draw a circle of diameter 30 mm over here. As it bisects the axis, here this distance would be half than the total height. So draw a circle of diameter 30 mm. From this circle, take projection lines on both the sides and draw a rectangle over here in front view, and by taking projections in the top view, draw a rectangle in top view as well. After drawing three views of this horizontal cylinder, let me pick up the points of intersection between these two cylinders. So for that, what should we do? So for that, let me take the points of intersection, and for that we divide this circle into equal number of parts. So we divide this circle into 8 parts, 1, 2, 3, 4, 5, 6, 7 and 8. So 8 divisions are made of this circle. Now project these 8 endpoints to its side view and front view. So for that, from 1, draw vertical line, horizontal line, 2, vertical line, horizontal line, 3, 4, 5, 6 and so on. So here 1, 2, 3, 4, 5, 6, 7 and 8 points are there in the side view. Similarly, from all these points draw horizontal lines. So it will show the imaginary generators over this cylinder like this: 1, 2, 3, 4, 5, 6, 7 and 8. After drawing this imaginary generator, what should we do? We need to find out the points of intersection between this horizontal cylinder and this vertical cylinder. So for that, from point 1, draw vertical line that will cut this black cylinder at point number 1. Vertical line from point 2 that will cut cylinder over here, that is point number 2. Vertical line from point 3, this is point number 3. Vertical line from 4, 5, 6, 7, 8 and 1. So these are the position of the points of intersection in top view. Now to find out the position of these points in front view, let me take projections from top view. Draw vertical lines from 1 over here. From 1, draw vertical line that will cut horizontal line from point 1 over here. This is point number P1 dash. Similarly, to find out position of P2, from point 2 draw vertical line, and from this 2 draw horizontal line. Both will intersect at point number P2. This is point number P2. Somewhere here, this is point number P2. Point number P3 would be here. From 3 draw vertical line. So this is point number P3 dash. P4 dash would be here. P5 dash, P6 dash, P7 dash, P8 days and again P1 days. So here smooth curve would be there. So join all these points with the smooth curve like this. So that shows the curves of intersection between these two solids. Similarly, on this side also we can locate the position of the points by drawing the points on this side. So here point number 1 is there, 2, 3, 4, 5, 6, 7, 8 points would be there. Draw vertical lines from all these points, and on this side also we can draw the same curve as drawn over here. So this would be the curve of intersection. Now again, this red colored cylinder, which is horizontal cylinder, each pass through the black colored vertical cylinder, these edges would not be visible. Hence these edges should be drawn with the dotted lines like this. This is dotted line, this is dotted line. And in top view also, these edges would not be visible. Hence they should be drawn with the dotted line like this. Dotted line 1 and 2. So this is the solution of this problem. Name the views: front view, left hand side view, its top view. You need to insert the dimensions, like this is diameter 40 mm, this is diameter 60 mm, 40 and 30, and height is given as 80 mm in both the cases. Now we discuss another problem. Draw the development of square pyramid as shown in figure. In figure, a square pyramid is given like this. This is the given problem. A square pyramid is given like this. In examination, you are just given these drawings, and a square pyramid is given like this. Square 50 mm dimension, which makes an angle of 45 degree with XY line. This is slant length of slant edges. It is cut like this from here, here, here and here. This height is given as 20 mm. So this is 20 mm. At height of 20 mm, it is cut. So how to draw the development of this case? So for this, as we know, the development of square pyramid would be 4 triangles.